I want to explain to you in detail how to build each part of this machine and avoid making the same mistakes I did. I'm EK and you're watching Dynamic Systems. Base structure. It doesn't look like there are any special tips here, but pay attention to these points. Weld the top rectangle first and separately to make sure it's not distorted. Fill every gap and weld every edge. Heat the whole structure or let it rest for months in an open area to relieve all the stresses. Sand the structure and welds until you meet the shine of the metal everywhere. Apply multiple layers of anti-rust paint before applying the color paint. Epoxy leveling. Find a place with a level floor, mold your top rectangle and pour 1 or 1.1 kilogram of epoxy resin. I recommend adding black dye to your resin as it will absorb more heat from the environment, which helps the resin to cure faster. Also, you'll spot every potential leak immediately. Bed profiles. Once you have finished cutting the profiles, send them to grinding for all their surfaces. Inform the machine shop that you require the same dimensions for all pieces, and parallelism and perpendicularity are also crucial. After grinding, you have nice references for the next machining operations, alignment, and fine-tuning during the assembly phase. The bed profiles have simple machining to do, but one feature has crucial tolerances, and it's the location and diameter of the pinholes, because they determine the positioning of your Y-axis profiles on the machine core. Other holes are just the clearance path for the threaded rods to get through. They don't require any special tolerances. After finishing the machining for the bed profiles, grind the top contact surface again, but just in a tiny and equal amount to wipe the deformations from the machining process. You are not allowed to do any operation on these parts after the final grinding. Literally nothing, or you ruin the flatness and the hole tolerances. Y-axis profiles. We have the same scenario here, just like the bed profiles. First, you should grind all surfaces, next do the machining, and at the end, finish the bottom surface with another equal amount of grinding. We have the locating pinholes under the profile and the bolt clearance holes again. The vertical side of the profile is used as the reference on the technical drawing, because when the machinist flips the profile for the other operations on the top surface, the ground side surface will be used to locate upper side features to machine. As I mentioned before, the rail mount channel is too narrow for grinding operations. If it was impossible for you to, then inform the machinist about the importance of surface quality, flatness, and straightness for this feature on all its sides. Actually, the main critical tolerances here are the dimensions and locations for the pinholes and parallelism of the rail mount channel with them and the bottom surface. Once more, you need to grind the bottom surface at the end and not to do anything after that. Gantry carriage blocks. Here we need to get two CK45 square bars with an 80 by 80 mm cross section and 190 mm in length. 5 mm of the length is for the tolerances of the cutting tool when you purchase the raw material, and you should machine it down to 185.2 mm. Then send them for grinding on all 6 faces to get them square. The central hole should be machined first. The most important tolerance is parallelism between this hole and the other faces. After that, you can proceed with the wider flange section for the housing of the ball screw nut. Next, the linear blocks housing channel should be machined. The depth is important here, and we need the same particular distance between this contact surface and the central hole on both blocks. Consider a plus 0.1 mm extra margin for the grinding step at the end. Finally, you can machine the threaded holes on the bottom and the top side. We have another pair of locating guide pin holes, which should have the highest tolerance here, both about the diameter and location. The next step is stress relieving and thermal hardening operations. Regarding grinding, the important point is that the top side should be ground first and with the same depth for both blocks. Then the same process for the surfaces in the channels as well. Gantry Profile. For the gantry profile, we begin with grinding all four sides. Then we can machine the rail mounts on this face with a plus 0.1 mm margin for grinding. Ball screw supports cannot be ground at the same time as the rail mounts, so we just machine them as close as possible with the final tolerances, which will be the depth of the rail mounts after their grinding operation. We need to grind the rail mounts to make sure there is a final reference for the alignment when we machine pinholes and bolt clearance holes under the profile. After machining the pin and bolt holes, it's time to finish the part with another grinding for the final tolerance on the bottom surface. Gantry right angle support. As the contact surface between the gantry profile and the gantry carriage blocks is not enough to keep it balanced in counterbalance with the Z module's weight, we need to use these right angle supports. To build them, first we need to cut the piece out of CK45 sheet with 25 mm thickness, using a precision water jet cutter with 0.05 mm margin, then drilling the bolt clearance holes and threaded holes as well. Next, a heat treatment and hardening process is needed to relieve any potential internal stress and make sure they bear all the torques from the gantry profile and remain in shape and position. And grinding at the end to make sure they are right angle with the tightest possible tolerance. X-axis carriage sheet. The raw material is a CK45 sheet, 30 mm thick. It should be cut with a plus 5 mm margin in the overall dimension first. Then we need to grind both surfaces before machining the edges and bring it to the desired rectangle we need. Also with a plus 0.1 mm margin on sides to do another grinding process. Then we have the exact dimensions of the rectangle, so we proceed to machine the central pinhole precisely, because this hole will be the main reference for the other features. We machine a step-down surface for the linear blocks with 0.05 mm grinding margin, and add the housing for the ball screw nut after that. Remember to machine tiny grooves here as well for the grinding process. Other holes are just bolt clearance and threaded holes, so easy to machine or drill. After machining, we do the thermal stress relief and hardening, and finish both sides with another grinding step to get the final tolerances. The overall thickness doesn't have any absolute tolerance. The only crucial dimension is the depth of the ball screw nut housing. Z-axis carriage sheet and Z-axis sheet. As I mentioned in the previous video, the Z-axis carriage sheet is very similar to the X-axis carriage sheet, so we don't need to talk about the same tips again. And the Z-axis sheet also needs the same operations and order to them as well. Just remember that due to the longer length of this component, you may face more distortion after stress relief and hardening operation. That means the margin of grinding should be around 0.1 or 0.12 for rail mounts and the spindle side as well. Z-motor flange and side support sheets. I used a standard motor mounting bracket for the X-axis, but for the Z-axis I designed a customized flange to help with the rigidity in combination with the Z-side support sheets. Both are CK45 again, but the hardening is not necessary for the flange. Just machining after first grinding preparation of the raw material is enough. The crucial tolerance is equality in width to provide a consistent side surface to attach these support sheets tightly. For these support sheets, we get a piece of CK45 with 15 mm of thickness. First, we do the hardening process on the raw material, and second, we grind it to remove 0.5 mm on each side and left with 14 mm flat thickness. At the end, we cut out both components from the same sheet using a water jet cutter. Ball screws. After getting the ball screws, the outer hardened layer should be removed by grinding. Because it's difficult to machine it by a lathe, also it would cause damage to the ball screw as well and ruin the tolerances. When the hardened layer is removed, it's easier to machine the custom diameters and threads, but still you might break some threading tools before finishing the job. Just be patient and careful not to cause the ball screw to run out. After the grinding process, final tolerances will be achieved and the ball screw is ready for localized hardening to give it back the hard surface we removed. Y-axis ball screw supports. This component must be made from aluminum. The raw material consists of two pieces of 70-75 T6 square bars, each measuring 90 by 90 mm in cross-section and 115 mm in length. The critical tolerance is the distance and parallelism between the ball screw support axis and the bottom surface of the part. T6 indicates that the heat treatment for this alloy has already been completed and no additional heat treatment is required. However, care must be taken during machining to avoid distortion caused by high cutting loads and feed rates.